Let's move now to inter-process communication. The example I made with Google Chrome is just one of many examples you can make about why processes need to communicate between them. In Google Chrome, you have tabs. Each tab is a process, but you have dedicated processes, for instance, to render the HTML text of each page. And in that case, the renderer and each tab will need to communicate. Now, the operating system allows processes, provides, let's say, functionality that allows processes to communicate. There can be different reasons, information sharing, computation speed up, modularity, and so on. There are two main ways in which two processes can communicate. They can share memory or they can exchange messages. When you exchange message, you basically rely on the operating system to maintain the communication channel, okay? While when you rely on shared memory, you take care of the communication yourself in between the processes without involving the operating system. Independently of which one of the two methods you use, you have always the producer-consumer problem when you have communication between processes. And it's about decisions you have to take about the modes in which the different processes will communicate, okay? You can either go for an unbounded buffer, so you can prevent putting a practical limit on the size of the buffer, but then you need to make sure that the producer will not keep adding stuff if the receiver, the reader, cannot keep up at the same speed at which the messages are being sent. Or you need to put a bounded buffer, which will help in stopping the producer if a maximum number of messages that still have to be read or retrieved still exist in between the two processes. If we look a bit better here, so with shared memory, you create a common space between two processes, and you can directly exchange messages without relying on the operating system. It's faster because you don't have to send a message to the operating system, store it somewhere at the operating system level, and then wait for the operating system to deliver this message to the other process. But on the other end, it's more complicated to synchronize. You need to make sure that, for instance, who has to read a certain value does not read the value before it has been completely written by who has to write the value, or that a process does not delete a certain value if that could be critical afterwards, and so on. So the synchronization needs to be handled by the processes themselves. On the other hand, if you use message passing that is managed directly by the operating system, it might perform not as good as the shared memory, but on the other hand, it becomes way simpler to, let's say, maintain, at least from the perspective of the process, because you don't need to synchronize processes yourself. You can rely on the operating system. This does not mean that this is simpler, okay? Especially if you look at this from the operating system point of view, there are a lot of issues that you have to take into account, how to establish the links, how to create, let's say, communication channels that could be shared among more than two processes, for instance, and so on and so forth, okay? Now we are going to look at a specific example of inter-process communication with message passing maintained by the operating system.